Hi everyone. Today's lesson we are focusing on how do we find the terms of an arithmetic sequence. So consider the given arithmetic sequence 8, 18, 28, 38, 48 and so on. So therefore, let's actually find. So there is a separate formula to find the term of an arithmetic sequence. I will just show you, I will prove the formula using this example. So here the first term is equal to 8. So therefore we have T1 is equal to 8. So A is referred to as the first term. Next, the second term, what is the second term here? T2 is equal to 8 plus 10 because the common difference here is 10 here, isn't it? So T1 is equal to 8, D is equal to 10 because 18 minus 8 is 10. So T2 we can write it as 8 plus 10. So therefore here we write it as T2 is equal to A plus 1 times D. Next, what is the third term? Third term we can write it as 8 plus 10 plus 10. I'm just writing it in this form in order to prove the formula. So third term is 28. We can write this as 8 plus 10 plus 10, which is again 28. So in general form, we write T3 is equal to A plus 2 times of D because the common difference is D. So 8 plus 2 times of 10 will give you 28. Let's look at the fourth term. Fourth term is 38. We can write this as 8 plus 10 plus 10 plus 10. So therefore in general form we write T4 is equal to A plus 3 times of D. So therefore how we can write it in general form? So Tn, what is Tn is equal to? Tn is equal to 8 plus n minus 1 times D. Okay, so here you can see the fourth term is referred to as A plus 3D. So how do we write in general form? Tn is equal to 8 plus. So therefore we can write this as Tn is equal to A plus n minus 1 times D. Okay, so when it is the fourth term, we write it as A plus 3 times of D. So it is always 1 less than the term value. So therefore, it's not the term value, the term number. So Tn. So in order to find a particular term in an arithmetic sequence, we use the formula Tn is equal to A plus n minus 1 times D. Because we can't actually add the common difference each time. For example, if we have to find the 100th term, we definitely need to use this simple formula, and we can derive the 100th term. So Tn is referred to as the nth term, A is the first term, and D is the common difference. So let's look at an example in here. Find the 20th term of a sequence. Find the 20th term of the sequence 5, 40, 75, 110, and 145, and so on. So it's an infinite arithmetic sequence. So in order to find a particular term, what is the formula we use? Tn is equal to A plus n minus 1 times D. So we need to know the value for A and D. So A is equal to 5 and D is the common difference. So D is equal to 40 minus 5. That will give you 35. So now we have to just use the formula. So Tn is representing T20. So therefore n is equal to 20. Here I'll just write it down. N is equal to 20. So we are actually finding the value for the 20th term. So T20 is equal to 5 plus, so we replace n as 20 because we are finding the 20th term. 20 minus 1 times 35. So therefore we have 5 plus 19 times 35. So that will give you the 20th term is equal to 670. So therefore for this particular sequence 5, 40, 75, where the first term is 5 and the common difference is 35, in order to get the 20th term, we use the formula Tn is equal to a plus n minus 1 times d. So therefore, we replace a as 5, d is 35, n is 20. So now we have, okay, so let's look at another example where the third term is minus 1 and the fifth term is 11. So how do we actually get the first term and the common difference? So the third term is minus 1. So we can use the the general term, which is a plus n minus 1 times d formula. So therefore t3 is equal to a plus 2d. That is equal to negative 1. Similarly, we can also use, so therefore I'll just write down that formula. Tn is equal to a plus n minus 1 times d. So therefore t5. So how do we rewrite the fifth term as an equation using this formula? So a plus n is 5 here. So 5 minus 1 times d. So therefore t5 is equal to a plus 4d. So we know that the fifth term is 11. So we can replace t5 as 11. 11 is equal to a plus 4d. Now we can actually use the simultaneous equation method to solve for a and t. So we have t5 and t3. So we have got two equations. We'll just write the two equations one below the other. So the first equation is a plus 2d is equal to minus 1. And then we can write this as a plus 4d is equal to 11. So we have it in the form of, instead of x and y, we have a and d here. So therefore, using the elimination method in simultaneous equation, it is easier to solve for a and d. So when we subtract this equation, so when we're subtracting it, just change the sign of the second equation. So plus becomes minus, and plus becomes minus here, again it becomes minus. So when we subtract, a is eliminated, a minus a is 0. So 2 minus 4 is minus 2d is equal to minus 12. So we have minus and minus on both sides. We can cancel off the minus. So d is equal to 12 divided by 2. That gives you d is equal to 6. So we have the common difference as 6. So we can substitute the value of t in any one of the equation. So we'll just choose the easiest one, the first equation. So substitute. So it's better I name this as 1 and 2. So therefore substitute d is equal to 6 in equation. Either in equation 1 or 2, it will give the same answer. So equation 1 is a plus 2d is equal to minus 1. A plus 2d is equal to minus 1. And therefore, we can substitute a plus 2 times of 6 is equal to minus 1. So therefore, here we get a plus 12 is equal to minus 1. So a is equal to minus 1 minus 12. That will give you a is equal to minus 13. So we have a is equal to minus 13 and d is equal to 6. So we have actually found the value for a and d. Now we can actually find the value of any term. So if, for example, if we have to find the 50th term, t50 is equal to minus 13, a plus n minus 1 times d. So minus 13 plus n minus 1, so 50 minus 1 times d. Okay. So we have here minus 13 plus 49 times 6 will give you the 50th term. So therefore we have minus 13 plus 49 times 6 will give you the 50th term. So minus 13 plus 49 times 6 will give you 2 94. So that will give you 294 minus 13 is 281. So therefore, we have the 50th term. So therefore, let's actually do a quick review of this example. So in this example, we have the two terms, which is the third term and the fifth term. So in order to get the first term and the common difference, we make use of the formula Tn is equal to a plus n minus 1 times d. So therefore, we frame an equation using the third term and the fifth term. So third term, we can write it as a plus 2d is equal to minus 1. Fifth term can be written as a plus 4d is equal to 11 using the common term formula. And then we have to use the simultaneous equation elimination method to solve for a and d. So I've actually subtracted the equation. So in order to eliminate a, so the d value is 6 here. Substitute the d value in any one of the equation and then we get a is equal to minus 13. So using the first term and the common difference, we can find any term. So using this, we can actually find the 50th term using the formula a plus n minus 1 times d. So now we have t50 is equal to 281.